Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Continuing answering February, March 2022, paper 2-2. Question 15. Smoke particles illuminated by a bright light are seen through a microscope. They move about randomly. What causes this motion? Yes, there is attraction force between the particles, but that not what causes this random motion between it and the air molecules. There is collisions, yes, between the smoke particles and the air molecules, which is our answer, I think. C, evaporation of the fast-moving smoke particles. No. Warming of the smoke particles by the lamp. Yes, it's a correct statement, but this does not explain the random movement, so the correct answer is B. Question 15. Ether is a liquid that evaporates easily at room water temperature. The rate at which ether evaporates can be increased by bubbling air through it. The diagram shows the process. So we pump air into the ether, the bubbles of the air get out, carrying the evaporation ether from it. Students give 3 suggestions why the rate of evaporation increases when the air is bubbled through. Student 1 suggests that the temperature of the ether is decreased. Student 2 suggests that the surface area of the ether is increased. Student 3 suggests that evaporated molecules are removed at greater rate. Which students are correct? Yes, send me on the chat. Thank you, Muhammad. Thank you, Maryam. Good, Hazem. Okay, all of you are correct. Now, it's correct that the ether temperature decreases, but that doesn't make the increase of the evaporation. Why the rate of evaporation increases? This is not the reason. So when the surface area increased by the bubbles, also the air molecules carry out as they move out, the evaporated ether gas particles. So the correct answer is student 2 and student 3. Number 17. Some ice, frozen water, is slowly heated at the temperature its temperature is measured. The graph is plotted of the temperature against time. Which row describes what happens to the thermal energy and to the temperature in section X? Thermal energy, of course, is gained. Of course, even if the temperature remains constant. So the correct answer is B. Question 18. The diagram shows apparatus needed for the experiment to determine the specific heat capacity of the material from which the object is made. So what do we have? We have a heater that connected to a voltmeter and a meter to measure both current and voltage to know how much is the power, and the stopwatch to measure the time of heating from the heater, and thermometer to know how much the initial and the final temperature, and a balance to measure how much is the mass of the object. Which piece apparatus could be omitted if the purpose of the experiment is to determine the thermal capacity, not the specific heat capacity of the object? Now we know that energy equal mass times specific heat capacity times change in temperature. And the energy is power multiplied by time, so VIT, voltage current time, multiplied by the mass, by the specific heat capacity, multiplied by the change in temperature. Now, both of mass and specific heat capacity together, they called what? Thermal capacity, multiplied by what? The change in temperature. So the only thing that I can remove it from our measurements here in the apparatus is the balance, so I don't need the mass here, because the thermal capacity is equal to voltage times current times time divided by the change in temperature. So I need the voltage, the ammeter, the thermometer, and the stopwatch. Question 19. Both boiling and evaporation are involved. Both boiling and evaporation involve a change of the state from liquid into gas. Which row gives the correct difference between boiling and evaporation? Send me on the chat. Boiling. No bubbles are formed? There is bubbles formed. Okay. Occurs at all temperature? No, at boiling temperature. Occurs throughout the liquid? Yes. The temperature falls? No, it remains constant. Let's check. So the answer is C. Let's check the other side. Evaporation. Bubbles are formed for evaporation? No. Occurs at defined temperature? Of course not. Occurs only at the surface? Yes, correct. The temperature remains constant? Of course not. So the correct answer is C for this question. Question number 20. Which statement describes thermal conduction in a metal by what? By electrons. Atoms and electrons move freely throughout the metals. That's not correct. The atoms, they don't, right? Part B. Atoms and electrons vibrate. Atoms, they do, but electrons, they don't. They don't vibrate about their fixed positions only. Electrons move freely throughout the metal. Electrons remains attracted to the atoms. This is not correct. So the correct answer is what? Is C. 21. A tank contains water. Ripples are produced on the surface of water. Refraction is observed. Now we know that according to the 6 S's that we studied, okay, that refraction happens when the speed decreases or changes, when the wavelength changes. So but the frequency remains constant, the angle becomes smaller, etc. Okay, what causes the ripples to refract? A, the cold water in the tank replaced by warm water? No, what's that? The ripples change speed, yes, as they move from deep to shallow water. This is correct. C, the ripples hit by wall of the tank. Yes, this is called reflection, not refraction. Okay. D, the ripples pass through a narrow gap. That's called diffraction. So the correct answer is what? Is part B. Next. 22. The diagram shows waveforms of the water wave passing through a gap in a barrier. We have a barrier, we have wavelength. We can see that the center of the gap, the waves continue, okay, straight line without changing direction, but at the edges it diffracts a little bit. Which change will increase the diffraction of the wave as passed through the gap? Now, here, this situation is when the gap is greater than the wavelength. They asked how we can make what the diffraction occurs more, increase diffraction. So that means I need to make the gap less than or equal to the what? To the wavelength. A, increase the amplitude of the wave. That's not included. B, increase the width of the gap. C, reduce the depth of the water. D, reduce the frequency. What do you think? Which one is the correct answer? Thank you, Muhammad. Thank you, Ahmad. Yes, Mariam. Good. Excellent, Sarah. Now, all of you are correct except one. What do we have? Increase the width of the gap. If we increase the width of the gap, that means it will be partial diffraction more. I need to make the gap smaller than the wavelength. So this is not correct. Reduce the depth. Okay, as the depth is reduced, that means with the speed, okay, becomes what? Smaller. And that causes the wavelength to become what? Smaller. We need to make the wavelength bigger than the gap, or the gap smaller than the wavelength. Reduce the frequency. Now we know the speed equals frequency times what? Wavelength. So as the frequency is decreased, the wavelength increase at the same speed, at the same depth. So the wavelength increase. So the correct answer in this part is D, as you told me. Next, question 23. The diagrams each show a ray of light from an object, all passing through a thin converging lens. The principal focuses in each diagram are labeled F. So we have an object. This is the first ray, passed through the optical center, doesn't change its direction. The second ray is parallel to the principal axis, it refracts. Number 3, the ray comes from the object, all pass through the principal focus. Okay, then it refracts parallel to the principal axis. Which diagrams are correct? Thank you, Mariam. Thank you, Muhammad. Thank you, Sandra. Correct. Yes. Number 1 and number 3 are correct, while number 2, the ray which is parallel to the principal axis, it's supposed to refract through the focus, not random position. So the correct answer is C, number 1 and 3, correct. Next, 24. The diagram shows a ray of light inside an optical fiber approaching point X. This is point X, this is Q, P, and this is the surface as a tangent of the point X. The light is totally reflected within the fiber, total interreflection. The refracted index of the material of the optical fiber is 1.39, which condition ensures that the total interreflection occurs. Now we know that we have to know how much is the critical angle, and we know that the critical angle is sine inverse for what? For 1 over the refractive index, which is what? 1.39. So sine inverse for 1 over 1.39 by using calculator, the answer is 40.6 degrees. Now we know that Q is the angle of incidence. The angle of incidence is supposed to be greater than the critical angle, so the correct answer is B. Q is supposed to be more than 47, not less than, and P, it's supposed to be very small if we subtract 90 minus 46, okay, so that's not the answer, okay, and P and Q, if they are equal, that means 45, total interreflection will not happen, total interreflection at 45 degrees. Number 25. An eclipse, an eclipse of sun happens when the moon comes between the earth and the sun. This is the sun, this is the moon, and this is the earth. Some of the light of the sun will not reach this spot or this area on what? On the earth, so that makes an eclipse for the sun in this region here. Which statement is correct? Infrared radiation from the sun disappear before visible light and ultraviolet. B, ultraviolet radiation from the sun will disappear before visible light and infrared radiation. C, visible light from the sun will disappear, before ultraviolet radiation and infrared. D, infrared radiation, ultraviolet radiation, and visible light from the sun all disappear at the same moment. What do you think? Send me in the chat. Okay, Hazem, thank you. Good, Tariq. Thank you, Kareem and Muhammad, Mariam. Oh, exactly. All of you are correct. The correct answer is D. All the rays that come from the sun are blocked, so they will disappear. So the answer is D. Number 25, the diagram shows air particles and sound wave. You can see that in some regions they are close from each other, causing compression, or the regions that are far causes rarefaction. Which row correctly, okay, undefine the position of compressions and the position of rarefaction? Compression, X, yes, it's compression. Y, no, it's not. V, yes, it is compression. Z, yes, it is compression. The molecules are close. Rarefaction, Y, yes, it is rarefaction, so our answer is A. Let's check. X, no. Z, no. And Z, no. And sorry, V, no. So the correct answer is A. Number 29. Two isolated metal spheres are both negatively charged. The spheres are brought close to each other, okay, but do not touch. Which diagram shows the charge distribution on the spheres? Now, you know that negative charges, the electrons are negatively charged, they move away from each other, they will repel since they are metal, so they are free to move. So which one is the answer? Yes, thank you, thank you, thank you. So the correct answer is D. 28. Two separated circuits have different power stations. Both power supplies provided with the same magnitude of current, so we have same current. Power supply P has electromotive force of 1.5, while power supply Q has an EMF of 3 volt. 3 volt, that means Q has twice voltage. Which is stated about Q is correct when compared with P. Q supplies twice the charge per unit of time. Now we know that we have the same current, the same T. So that means charge divided by time is the same. Q supplies twice energy per unit of charge. Now, according to the definition of voltage, energy per charge, so whenever Q has 3 volts, that means the energy per unit of charge that will be greater. 3. Q supplies twice energy per unit of time. Of course, since we are talking about same current, that means the energy is more. So the correct answer is 2 and 3, which is D. Number 29.